Welcome back, honors. This is our last section of our review unit. So we are preparing for our test now. So again, last section, our test is coming up. So we will talk about that in class. Our last section is absolute value equations and inequalities, which is 1-6. A long title. It's like a long, awkward pause, awkward silence, I guess I should say. And I just fill it by rambling. Okay, so let's start with equations and what we would do to solve an absolute value equation. So I'm going to do an example on the left-hand side, and then I'm going to do steps on the right-hand side. So if I gave you the absolute, or the example, the absolute value of x plus 4 plus 3 equals 5, our first step in solving any absolute value expression, equation, inequality, this is always going to be the same. It's going to be to isolate the absolute value expression. I have to make sure we're split in half here. Okay. So first up, isolate the absolute value expression. Okay, so in this case, the absolute value expression is this x plus 4. So what that means is our first step is to move this 3 to the other side of the equation. So that's what I'm going to do first. I'm going to subtract 3 from both sides of the equation. And so the absolute value of x plus 4 just comes down. And now it's equal to 2. Now, something that's super important with absolute values, they're not parentheses. They're grouping symbols, but they're not parentheses. That's something where it's something you can distribute to. So that's going to be really, really important. Do not distribute into an absolute value expression. Okay, so when we do that, so let me explain that one more time. So let's say I had a 2 out here. Instead of distributing that, if I had the 2, I would have brought that down. And then to continue isolating the absolute value expression, I would have divided both sides by 2. So we don't ever distribute the 2 or whatever the number is on the outside of the absolute value expression. We always divide it off to get rid of it. Okay, so now once the absolute value expression is isolated, our next step is to split it into equations. So when we split it into 2 equations, we're getting rid of now the absolute value symbols itself. So one of them is going to be x plus 4 is equal to 2. Nothing changes. It's the exact same thing. Now our other one is going to be x plus 4 equals -2. Now, why are we considering the negative option? Well, remember, if I got in here a negative answer, it would come out to be the +2. So what we also have to consider is if we plug in something and it gets us like a negative answer, but makes it positive because of the absolute value expression, we have to take into account both the positive value and the negative value, which is why we have to split it into 2 equations. So our two equations where the answer is the same sign, which is always going to be positive. And we'll talk about it if it's not. And then the answer is the opposite sign. Which is always going to be negative. So one where it's the same sign, one where it's the opposite sign. Now, one of the most common mistakes that people make in solving absolute value equations or inequalities is that they change what's in the inside of the absolute value symbols, and that's a no-no. So let's write that down because that's super important. Do not change what is inside the absolute value symbols. Okay, so now we have basically the easiest step is just to solve each equation separately. So let me get another colored pen here. And that's my step 3. Solve each equation separately. This is a really hard word for me to spell. And I don't think I spelled it right, but that's okay. I'll learn. I think it's an A. I Googled it. It's an A. Ooh, okay. That would have been so embarrassing. English is hard. Okay, so we're going to solve each equation separately. So all we're going to do is I'm just going to look at this one on its own. I'm going to subtract 4 from both sides. And I get x is equal to 2, negative 2. And then I'm going to subtract 4 from both sides here. And I get x is equal to negative 6. And now I have my two solutions. My two solutions are x is equal to negative 2 and x is equal to negative 6. And those are your steps for solving absolute value equations. So let's get into solving absolute value inequalities, and then we'll do some more examples. We'll focus primarily on inequalities because those are the more challenging ones, but we'll do some examples of equations also. Okay, so inequalities. Yeah, okay. So your first step is the same exact step. We're not going to rewrite it, but this, I should write an example that would help. So an example is going to be 1 minus 2x, the absolute value of that, plus 6 is greater than or equal to 9. So the first step, like I was saying, the first step is the exact same as an equation. We want to isolate the absolute value expression. So that means we're going to go in here. I'm not going to rewrite those steps. And we are going to subtract 6 from both sides. And so when I write that, I have the absolute value of 1 minus 2x is now greater than or equal to 3. Same idea too, do not distribute into an absolute value expression. That doesn't change here with an inequality versus an equation. But what we are going to talk about is our splitting aspect. So the splitting aspect is pretty similar. There's just one aspect that's different. So when splitting the inequalities, so let's see, it's here, okay. When splitting the inequalities. So one of my inequalities is going to be 1 minus 2x is greater than or equal to 3, where it's the Same symbol, same sign. So same inequality symbol, same sign. Okay, the other one is going to be 1 minus 2x is less than or equal to negative 3. So now what happened is it's the flipped inequality symbol on the opposite sign. So when you change the sign, you change the inequality symbol as well. So opposite inequality symbol. Opposite sign. I'm hoping I can squeeze it in there. Okay, so then we continue on. Same thing, same idea here. Do not change what is inside the absolute value symbols. That doesn't change for equations versus inequalities. That stays the same concept there. And so now what we do, just like we did, we solve each inequality here separately. So I'm just going to focus on this one. I'm going to subtract 1 from both sides. So that's just going to be negative 2x is greater than or equal to 2. Divide both sides by negative 2. That should be like a light going off. We're dividing both sides of an inequality by a negative number, which means we need to flip the inequality sign. So that becomes x is less than or equal to negative 1. Okay, so I found that one. Let's find the second one. Subtract 1 from both sides. I have negative 2x is less than or equal to negative 4. Divide both sides by negative 2. Again, we're dividing both sides by a negative number, so I'm going to flip the inequality sign. X is greater than or equal to 2. So the only difference here is how we write our answers. Before, it's just x equals our 2 solutions. With an inequality, there's multiple solutions. So when we're graphing or we're writing our answer in in interval notation, we're writing it as 1. So we're using that union. So let's kind of make a few points here. Always graph the solutions on the same number line. And write your answer in interval notation. Whenever we're dealing with inequalities, we're always writing it in interval notation. So when I graph this, I'm going to first start by graphing to help me with interval notation. So we have negative 1 and 2. We're putting it on the same number line. So when I graph that, we know x is less than or equal to negative 1. So that's going to be a bracket going in the negative direction. And then we have x is greater than or equal to 2. So it's a bracket going in the positive direction. So then when I write that in interval notation, what I'm going to do is I'm just going to look at this from left to right. So it's going in the negative direction forever. So that means it's negative infinity. And it goes to negative 1 with a bracket. There's a gap. So to reference that gap, we use union. Starts back up at 2 with a bracket and goes on in the positive direction forever. And that's how I would write that in interval notation. Fun times. Okay, let's try some examples on your own, with me, together, separately, whatever. Okay. So number 1, I'm going to kind of have to bleed out to here. The absolute value of x plus 3 plus 2 is less than or equal to 10. So what I want you guys to do is just try that on your own. Look at the example from above, try that on your own, and then come back and check your work. Okay, so you can either just keep going with me or you can fast forward through me to just see the answer and see if you got there. So I would first isolate my absolute value expression, which is x plus 3 here. So that means I need to get rid of that plus 2. So I'm going to minus 2 from both sides. So I have the absolute value. I need to do this a little different. Actually, you know what I'm going to do? I'm going to move that and do this. Okay. So we have the absolute value of x plus 3 is less than or equal to 8. So now what I would do is I would split it into my two inequalities. So I'd have one where it was x plus 3 is less than or equal to 8, same inequality sign, same inequality symbol, same sign. And then another one where it's x plus 3 is greater than or equal to negative 8. So I flipped the inequality symbol, I flipped to the sign. And now I can just solve for them. So I would subtract 3 from both sides, and I get x is less than or equal to 5. And then subtract 3 from both sides, I get x is greater than or equal to negative 11. So from there, I solved, and now I just need to graph and write it in interval notation. So to do that, I'm just going to put my graph over here. They ran out of room. So I have negative 11 and positive 5. So it's less than or equal to positive 5 and greater than or equal to negative 11. So it's greater than, it's going to be a bracket because it's or equal to going in the positive direction. And then less than or equal to 5, it's a bracket because it's or equal to, and then it's connecting. So how do we write that in interval notation? So to write that in interval notation, I'm looking at it from left to right. It starts at negative 11 with a bracket, ends at 5 with a bracket. This one is the nice and easy one. It's just negative 11 to 5, like that. And that is your final answer. Okay, let's do a few more examples. We'll do some kind of quick ones to kind of see some different ideas here, but I'm going to turn my page. Okay, so let's go into the absolute value of 2x plus 8 plus 7 is equal to 5. So what would be the first step I would want to do here? And if you're saying to get the absolute value expression all by itself, you would be correct. And so to do that, we would subtract 7 from both sides. And I have the absolute value of 2x plus 8 is equal to 5 minus 7, which is negative 2. Now, what do we know about absolute value equations? Absolute value equations or absolute value expressions always equal a positive number. But wait, what's going on here? An absolute value is equal to a negative number. That doesn't make sense. So when you isolate the absolute value expression and you have it set equal to a negative number, that means there is no solution. There is no possible number that I can plug in for x that's going to get me an outcome of a negative answer. Ever. Not a 1. So an absolute value will never equal a negative number. So if it does, like it does here, that's when you have to stop and pause and think, what does this mean? And this one means no solution. Okay, let's try another one. If I gave you the absolute value of 3x is less than negative 5. So we know, again, absolute value is always going to be equal to a positive number. And this is saying a positive number is less than a negative number. Now, does that make sense? Is a positive number going to be less than a negative number? The answer is no. This is similar to number 2. There's no positive number that's ever going to be less than a negative number. So this is, again, no solution. And again, that's because an absolute value will always be positive. Yikes. And a positive will never be less than a negative number. Okay, sorry for my poor handwriting. Now, let's change that ordering around, actually, and let's look at another example. We have the absolute value of 3x is greater than negative 5. So I didn't change anything else except the inequality symbol. So greater than, so that means that an absolute value is always positive. So it's saying a positive is greater than a negative. Now, does that make sense? Is a positive greater than a negative? And the answer here, yeah, that does make sense. A positive is always going to be greater than a negative. So what that means for our answer here is all real solutions. Now, how do we write that in interval notation? No solution, you don't have to write in interval notation. All real solutions, you do. So it's what we were talking about before when I was saying like all real numbers is just negative infinity to positive infinity. So this one, all positive numbers will be greater than a negative every single time, which is why it works for all real solutions. All positive numbers will be greater than a negative. Okay, now if I were to graph that, if I were to ask you to graph that, what that would look like on a graph is if it's all real numbers, it's just a line going from left to right. And that's that. Okay, let's try another one. We'll only do 2 more. Okay, so why don't you guys try this one on your own, and then I'm going to do one with you. So try this one. 5. So if I gave you the absolute value of 2 minus 3x is greater than 1. So if you need to look back at your steps, use your steps. If you feel like you've got this, try this one on your own, and I'm going to kind of show you just step by step by step. Okay, so first step I did was I split it into my 2 inequalities. The absolute value expression was already by itself, so we have one inequality with the same symbol, same sign, and then we have one with the opposite symbol and the opposite sign. Now I'm going to go ahead and solve those. So first one, I just subtracted 2 from both sides. I divided both sides by a -3. When I divided both sides by a negative, I had to make sure I flipped the inequality symbol, which I did here. So that one's solved for. I'm going to solve the second one now. So I just started by subtracting 2 from both sides of my inequality. And then I divided both sides by a -3, which is a negative number. So I had to flip the inequality symbol, and I got x is greater than 1. So now I'm just going to graph it, and I'm going to write it in interval notation. So if you guys are feeling confident, do that on your own, and then come back and check your work. If not, I'll do that with you right now. So to graph it, we have 1/3 because 1/3 is less than 1. You're always writing these from least to greatest, especially in interval notation. So x is less than 1/3. Well, it's a parentheses because it's less than, not, or equal to. And then it's going in the negative direction. And then greater than 1. So again, parentheses going in the positive direction. So how do I write that in interval notation? So we're going in the negative direction forever. So it's negative infinity to 1/3. There's a gap, but they're still together. So union 1 to positive infinity. And that's your final answer. Okay, let's try one more. I'm going to do this one with you, and then we're done with absolute value and done with the review unit. Okay, so number 6, last one, absolute value of x squared plus x equals 12. So, is our absolute value expression isolated? And the answer is yes. So from there, what we're going to do is we're going to split it into our two equations. One equation where it's equal to the positive, so x squared plus x doesn't change, equals 12. And then the other one, x squared plus x equals the negative answer, so negative 12. And now I'm going to solve this. How do I solve this? Remember, with an x squared, whenever you guys have an x squared, anytime you guys see an x squared, remember, you're solving a quadratic. That's what it means. So you're always solving a quadratic by either factoring or using the quadratic formula. So let's make a little note of that. Solve a quadratic by factoring or by using the quadratic formula. Okay, so with both of those, our first step is always to make sure they're set equal to 0. I cannot just factor this and set both of those equal to 12. That would not work. That's not how factoring and solving works. Part of the whole method of like solving by factoring is that we're using the zero product property, which means that it has to be set equal to 0. So that's what I'm going to do first. I'm going to subtract 12 from both sides. So essentially what I'm going to do is I'm going to do the solving portion. And now that it's set equal to 0, I'm going to first try and see if I can factor that. So do I know two numbers that multiply together to get me negative 12 and add to get me positive 1? So if you need to write out your big X, you can write that out. And hopefully you're thinking, yes, I do know two numbers. Those two numbers are positive 4 and negative 3. Now, because a is equal to 1, I can go straight to the shortcut. I don't have to split the middle term. I can just go to x plus 4 times x minus 3. And now I have my factors. It's set equal to 0, so I can set each factor equal to 0 and solve for x. So subtract 4, I get x equals negative 4, add 3, and I get x equals positive 3. So I have some of my solutions. I've got to keep going on this one now too. So we're going to do the same thing. I need to set it equal to 0, so I'm going to add 12. Now again, I'm thinking, can I factor this? Do I know two numbers that multiply together to get me 12 and add to get me 1? And I don't, because it's positive and a positive. So that means the numbers either have to be both negative or both positive. There are no two numbers that multiply together to get me 12 and add to get me 1. So I'm going to use the quadratic formula here. So I'm going to plug that into the quadratic formula. X is equal to the opposite of b, so the opposite of 1, plus or minus b squared, so 1 squared, minus 4 times a, which is 1, times c, which is 12, divided by 2 times 1. Okay, let's keep going. Simplify this. So 1 squared is 1, 4 times 12 is 48. Well, what happens 1 minus 48 gets me a negative number. So negative 47, that is no solution here. Right now, we're only dealing with real solutions, so no real solution. So my only solutions to this problem are over here. So my answer, my final answer is negative 4 and 3. And that is it. And that is your answer. And that is it for our examples. Remember, if you guys have any questions, please bring them to class. Write them down somewhere so you don't forget. But make sure you guys are bringing questions if you have any. Okay? I hope you guys have a great day, and I will see you guys soon.